Hello everybody, this is Nageswara, Assistant Professor of Physics, Government Degree College, Chintalapudi. In this presentation, I will explain about Newton rings as a part of interference chapter. Actually, these Newton rings are discovered by Isaac Newton to explain the interference pattern when the plano-convex lens having large radius of curvature placed on the plane glass plate, there is interference occurs and the dark and bright fringes are in circular shape. So this is discovered by Newton, so that after his name it is says that Newton rings experiment. So in which this is the plano glass plate in which a plano convex lens having large radius of curvature is placed on the plane glass plate. If monochromatic light is incident normally on this system, it is reflected at the bottom of the curved surface and top of the glass plate. These two rays interfere each other and produce alternative dark and bright rings concentrate around the point of contact between the lens and glass plate. So this phenomena was first discovered by Newton, that is why the rings are known as Newton rings after his name. So experimental arrangement is as shown in this figure, in which this is a plain glass plate P on which a plano convex lens having large radius of curvature, that is L, is placed on the glass plate, where the curved surface is touched on the glass plate. Here, so in which at the center contact point the air film T is equal to 0, and where when we are going outside the air film thickness increases. When this is the glass plate G makes 45 degrees with the normal, when a light ray is incident on this glass plate partially reflected along this direction. So when a monochromatic light like sodium light is incident on the glass plate G, partially reflect along the combination of the lens and glass plate. Of course, these rays reflected at the bottom of the glass plate, curved surface and top of the plain glass plate and sent back. These rays came from the same source, that is same sodium light, and travel different distances and form interference. These interference rings can be viewed by using the micrometer eyepiece. This is the micrometer eyepiece. By using that we can see the interference fringes. Now these two reflected rays interfere and give rise to an interference pattern in the form of circular rings. These rings are localized in the air film and can be seen with a microscope focus on the film. So how can we explain these Newton rings? As shown in this figure, as usual, there is a convex lens, plain glass plate, and this is a plano convex lens. And if a ray is obliquely incident on this system, the ray incident at the bottom of the curved surface at C, where it is partially reflected along the C1 and partially transmitted along CD. Of course, at C and at D, again there is two rays are reflected back along the direction of 1 and 2. So this is only for understanding. These rays 1 and 2 interfere each other and produce interference. Of course, the ray 1 is reflected at the bottom of the curved surface without phase reversal, because there is an air film between those two places, so that there is no additional path reference lambda by 2 according to the Stokes. But when the ray is reflected at D, just where there is a glass plate, is a denser medium, So it is reflected at a D at the denser medium. So an additional path difference of lambda by 2 is added in the ray 2. These two rays interfere each other and produce interference rings. Now the path difference delta is equal to 2 mu t cos r plus lambda by 2, where lambda by 2 is the additional path difference due to the Stokes law, and 2 mu t cos r is according to the cosine principle. We know for the normal incidence, that is r is equal to 0, and for air film between curved surface and plane glass plate, so that there is mu is equal to 1. So the refractive index for the air is 1. So the path difference delta can be written as 2t plus lambda by 2. Of course, at the point of contact, it is nothing but the point of contact between this glass plate and curved surface at this place, that t is equal to 0. So t is equal to 0 is nothing but the path difference delta is equal to lambda by 2. So lambda by 2 is the condition for the dark ring, so that the central spot is dark. For the nth maximum, we know the path difference is n lambda, so that the total path difference to t plus lambda by 2 is equal to n lambda, so that the 2t is equal to, of course, 2n minus 1 into lambda by 2. So this expression shows the maximum of particular order will occur for a constant value of t. But we know t remains constant in a circle, because in this diagram, that is in this curved surface, at this place, of course, this is a circular place, the thickness t is remains constant. So the maximum is in the form of circle. So for different values of t, different maximas occur. So the bright fringes are in circular form. So Newton rings is in the form of circular shape. So that we know 2t plus lambda by 2 is n lambda for the bright ring, that is 2t is equal to 2n minus 1 into lambda by 2, where n is a constant, that is a natural number, that is 1, 2, 3, 4 and so on. So of course we know for the dark fringe, that is path difference dt plus lambda by 2 is equal to 2n minus 1 into lambda by 2. So that for this, from this above equation, 2t is equal to n lambda, where 2 lambda by 2 are cancelled. So this is the condition for dark ring, that is 2t is equal to n lambda. So where n is equal to integer, of course, that is 0, 1, 2, 3, 4 and so on. So we know the rays are reflected back, so these are called Newton rings by reflected light. To understand clearly mathematically, we can assume that in which LO L dash is a planes lens, that's a plano-convex lens, and AB is the plane glass plate. So where this plano-convex lens extended as a circle, whose radius is called radius of cross section, that is capital R, where t is the thickness of the nth bright ring, thus r is the radius of the nth bright ring. Now from this property of the circle, np into nq is equal to no, this is actually, this is p, nq into np is equal to no into nd. So substituting these values, we know nq is equal to small r, np is equal to small r, that is r into r, that is equal to NO, this is NO is equal to thickness of the air film, that is T, into ND, this is the distance, this is the total distance is 2r minus T, that is 2r minus T, that is r into r is equal to T into 2r minus T. After expansion, that is r square is equal to 2rt minus T square. We know small t is very small in comparison with the capital R. because we have the plano convex lens whose radius of curvature is very high. So t square may be negligible, so that r square is equal to 2rt. So the thickness of the air film T is equal to r square by 2r. So for a bright fringe, we know that is 2t is equal to 2n minus 1 into lambda by 2. So that t is replaced by this r square by 2. So that 2 into r square by 2r is equal to 2n minus 1 into lambda by 2, for which r square is equal to 2n minus 1 into lambda r by 2. But we know if d is the diameter of the bright ring, that is r is equal to, that is radius r is equal to d by 2, then from this d by 2 whole square, that is d square by 4 is equal to 2n minus 1 into lambda r by 2. So the diameter d is equal to square root of 2n minus 1 into square root of 2 lambda r. This is nothing but the diameter d is proportional to square root of 2n minus 1. So we know root of 2n minus 1 is the even odd number. So diameter of the bright ring is always directly proportional to square root of the odd natural number. Similarly, for a dark fringe, we know that 2 mu t, that is 2t, 2 into r square by 2r is equal to n lambda. For that r square is equal to n lambda r. We know similarly d r is equal to d by 2, we know. So that d square by 4 is equal to n lambda r, that is d square is equal to 4n lambda r. So the diameter of the dark ring d is equal to square root of 4n lambda r. So that is d is equal to square root of 2n into root of 4r, 4 lambda r. So that according to this, d is proportional to square root of dn. It is nothing but the diameter of the dark ring is directly proportional to natural number. So this is the analysis of the arrangement of dark rings and bright rings in an Newton rings experiment. Thank you.